Hi everybody, welcome. This is Jonathan Pavolani. I'm going to give you a quick overview on how to actually check out this machine here, the Datex Ohmeda Modulus 2 Plus, not to be confused with the Excel 210. So, a lot of you, when you're coming into Garcia's, you want to know how to check the machine out properly, and you cannot remember for whatever reason everything that I've taught you. I thought I'd just demonstrate a quick overview for it. So, here's the machine. As you can see, the hoses typically, when you come in, not be attached to anything. So you've got to do a couple of things here. So this is what I typically do. You yank the machine out. I think I'm going to angle it this way so that you can see behind it. The first thing you want to do is to go ahead and plug everything in. Before turning any machine on or plugging anything in, remember I taught you in class the flow meters you want to be all the way down. So I test to make sure that each of those are locked all the way down. So that when you plug in the high pressure and intermediate pressure systems, if they happen to be if they're all the way up, what's going to happen is they're going to just hit the roof, and then it might have a chance at cracking the float. So, don't be bashful. We have the pin index system, safety system here to prevent me from plugging anything else into the wrong socket. Oxygen, and then this is the vacuum for the scavenger. That one goes all the way over here, nice and solid. Okay, so we're plugged in. The next step we're going to do is we're going to check our dials here, and we can see that there's, of course there's no air, so all the pipeline and cylinder pressures will be 0. The pipeline pressure for nitrous oxide, as you can see, is about 55 psi, which is what we expect. Oxygen, same thing, and you can see that the cylinder pressure is 0. So before we do anything, we'll go ahead and turn this on. Very good. One of the first things I like to do to get it out of the way is to test the level of oxygen inside the oxygen cylinder. And in the process, you can test the oxygen failure protection device, which basically it's the proper engagement and disengagement of the alarm. So you're going to take the key here, and we're going to go back and look at the cylinder pressure here. We'll say, all right, if I crack it open, which all I do is just spin it counterclockwise, just a quarter turn. I see that it's at, I don't know, close to 2,000. You have to do this. Increase the flows to like 2 liters here. And then I'm going to disconnect oxygen. We're going to look at the gauge there for a second. We'll watch it go all the way down. Now if it's not moving fast enough for you, you have to increase the flow rate. So here we go. I'm going to increase it up to about 8 liters, and you will see better. It's not falling. Now why would it be falling, of course? It's because the actual oxygen cylinder is still open. So come around here and we'll take a look. So I'm going to close this like that. Now we'll go back and look at the gauge, and you should see that needle fall. And then when the alarm goes on, okay, that's the engagement of the OFPD, and then it should turn off properly when I plug this back in. Very good. Again, the reason why we bleed off the oxygen cylinder valve is so that the board-on pressure gauge doesn't get stuck at a higher level and give you a falsely high reading. Although that's mainly in theory. I think that the design of the valves these days are pretty intact. Okay, next thing, very important. This is your agent analyzer and end-tidal CO2 monitor. We're going to go ahead and turn this on because it takes about 3 to 5 minutes typically to warm up. So you don't want to leave it off until, and then go do an induction and then want to turn it on. You always have it ready to go there. All right, the next thing, bring your flows back down. Since my hands are here, we can test the one of the hypoxic guards, which is to be able to test the link device here. So you can see it's supposed to go all the way up to 10 and then all the way back down. See how I came up with nitrous oxide, I come back down with oxygen, and that tests the full functionality of that link system. Alright, the next thing that I do, I'll go back here, it's asking for default or previous. Typically, if you want to look at default limits and go through everything you can, but typically use previous limits. It's asking you to set the agent. So let's pretend we're going to use sevoflurane, and then you have to hit exit. It's ready to go. It's still warming up, so we got nothing going on there. The next thing we'll do is we'll test the circuit parts. So here you have the ventilator and bellows assembly. You got the bellows here, right? That's definitely on there. You have our peak inspiratory pressure gauge. This is the expiratory valve. This is the inspiratory valve. You can see little arrows that are pointed there. This is the ventilator inflow power switch, they call it, even though it doesn't actually have any power in it. If you want to be on the bag, you have to have it in the bag position. If you want it on the vent, you have to switch it to ventilator. Okay, so we'll switch it to bag for right now. Okay, so we're going to take the circuit, I'm going to remove this, and we'll do a couple things. Take this off. So now this bag can act as a lung. Okay, don't forget to do this. You actually have to turn it to ventilator. Okay, you can go to the actual ventilator control here. You have to turn it on. Okay. Now all the settings are here. Typically should be at 0. So if I want to actually see anything happen, I've got to turn the tidal volumes up, the respiratory rate, and then adjust the IE ratio. Now this is non-flow controlled, or not a flow compensating ventilator. So if you were to increase the flow rate to 4 liters, your tidal volumes would actually increase. So right now they're like 85 was the last tidal volume. And I just increased the flow rate. You can see it says it's 216 now. That's going to continue to increase until it matches what I've dialed in, close to 400. Alright? So I'm going to leave this here, and then what we're doing is we're testing the functionality and the intactness of the ventilator. We're looking at the peak inspiratory pressure valve. And in this case, you're going to want the APL valve all the way open. This is open towards you, and then closing it would be away from you. Alright, so that's basically at this point I go and get my medications ready, so we're finished, we're good to go. We're going to go ahead and spin everything back to 0, turn it off, go back to the bag. Okay, I'm going to swing the arm around it again. We're going to test part of the intermediate pressure system and the circuit and the intactness. There's a lot of places that we could leak in here, including the CO2 canisters, as well as any of the connections here. So you want to make sure that your sampling line is intact. You're going to close down the pop-off valve, and you're going to press the O2 flush valve, right? Until it says 40, and it should hold. Alright, so if it's holding, you have to remember, see how the pressure gauge keeps going up higher and higher? That's because my flow rates are still at 4 liters, so I'm going to bleed off a little bit there. Remember to bring your flows all the way down, because that's going to cover up any leak that you may have. So I'm holding here at 40, okay? That's very good. Bounces, that means I can give a positive pressure breath. I'm going to bleed it down to less than 15. So look here at the peak inspiratory pressure gauge, there we go, right at 10. And then I'm going to put my hand on the vaporizers. First the isoflurane. Now I'm going to open this like this, and what you want to do is watch the peak inspiratory pressure gauge when I open it. Ready? There should be no drop. This is testing the backflow valve inside the common gas outlet, so I do each one of those. And in addition, what that's doing is it's testing the interlink protection device. If you could look in the back here, if you come around on the back side of the anesthesia machine, this is the device that prevents you from giving 2 anesthetics at the same time. When I squeeze this and turn it, I cannot open this one. See, that's what enables only one of them to go. So when you depress, that is what protects the machine from giving 2 anesthetics at the same time. Alright, move on back around here. One of the other things that we look for is just the tightness and the intactness of the flutter valves there. We'll put our mask back on. Now we've got to test the oxygen meter here, which we're going to have one here on the agent analyzer. Our backup one is here on the actual ventilator. To test the oxygen sensor and calibrate it, we have to take the oxygen sensor off of the ventilator. And so what you do is just unscrew it. There's no threads. Right? We'll just drop this down here. Some people like to do this, and we're going to keep our eyes on the O2 value all the way over here. It's going to drop down to ideally 21%. Now, newer oxygen sensors are a lot faster. This one's going to kind of settle probably around 25 or 23%. And whatever value it is, you're going to take your thumb and you're going to move it down towards 21 or up towards 21. We'll see what it does. Now, if you have to ask yourself, is it better to be higher or lower? I would rather the oxygen meter measure low than high. And the reason why is because you'll hit 21% earlier and you have a greater chance of preventing a hypoxic mixture. So now, in all honesty, you're never going to be approaching values that are that low, I hope. So we're almost at 22% now. And if that's where it is, I think I'm going to bring it down just a tad. So I'm going to take my thumb here, I'm going to spin it a couple, and it says 21. And I'm good to go. Now regardless of whether it actually goes all the way back up to 100%, like if I do this for instance, right? Let's pretend it's going all the way up to 82. Do I care whether it gets to 100 or not? No, because really what I'm using this for is a hypoxic guard type device. It's to warn me if I'm getting my oxygen level too low. Alright, so that's that. The only other things that I want you to check are, you probably haven't seen this before, but on the CO2 absorbers, how do you manipulate these? Well, if they need to be replaced, you need to know how to get them out. So there's a little canister release here. So if you take your hand on the back, it's pretty strong. Spin it over like that. You see how everything kind of dropped down? You can take them out. Here's your soda lime absorber. Alright, so they only go one way. Just like that. You can rotate them, whatever you want. Typically we write the days that they were replaced. And you got to set it so that it's nice and flush. Okay, make sure that this is the water drain valve. Sometimes there's a lot of humidity that's on there. And once you're on here now, there's a lot of variability as you go up. So if I were to not have it perfectly centered, what would happen is I would have a leak. And I don't know if you can see this or not, but if I did it wrong, you can see that there's a space there. And this is necessary in order to complete the circuit. So you want to make sure it's absolutely flush. And then I'm going to take this, I'm going to lock it all the way over. Just like that. I'm good to go. And of course, anytime you do that, you're going to want to check the intactness of your circuit again. So you're going to lock down, the pop off again, take me back up to 40, and it should hold. And it does. So, now that we're done with that, pretty sure that's just about, those are the basics, I would say. The last part that you don't actually get to see very often is the scavenger. The way that you test that to make sure it's actually working is that you open up your APL valve all the way. Right? If you look down at the end of this purple hose, you see another green bag. On top of this is a spin knob that means more to the left or less scavenging. So the way that you know it's functioning properly is if I squeeze and spill gas over into the scavenger, you should see it deflate. Now, right now it's all the way off. So if I start to open it up again, spinning it counterclockwise, you see that it deflates again. Where is the ideal? I mean, you're rarely going to use it here because we rarely have mechanical ventilation, but you want it to be just about right. It typically is about 1 or 2 turns to the left. So that's about right there. Okay. After that, what I encourage you guys to do is, the bed is right here. Oftentimes if you see the machine all the way over like this, we just kind of leave it like here. What I encourage you to do is, what if you induce the patient and then they need to be ventilated with an assisted ventilation here? It's really hard if you had to ventilate this way. So what I encourage you to do is just in the very beginning, don't take over the operating room. There's nothing wrong with getting yourself set up for success. The machine's got wheels. I'm in a much better position to ventilate easily like this than I am if I were like this. Okay? And then as soon as the patient's asleep, after you've pre-oxygenated, you can yank this thing all the way back, move it out of the way. No big deal. Okay? Hope that helps you guys, and if I went too fast, press the rewind button.